Welcome to RehabAI, a data-driven rehabilitation planning tool. Rehabilitation is a journey, but too often it is guided by a one-size-fits-all map. This can lead to inefficient care and suboptimal patient's outcome. But with RehabAI, we have built a better way. Although this tool has been developed using an AI engine that runs on synthetic data, but can be extended to do more. This rehabilitation planning tool provides a personalized map. It uses a unique blend of behavioral economics and AI to understand not just the patient's clinical state, but also their personal preferences and potential biases in decision making. We can see a wide range of functionalities, model output recommendations, plan utility scores, and final recommendations. And we can see the plans, the intensities, the durations, frequency, cost, treatment burden. We can also see the utility scores displayed and also the final aggregated scores. So the way this tool works is it takes in patient-specific inputs in real time, and it predicts their preferences. It analyzes a range of therapy plans. You can see the therapy plans, and of course, should these projects be funded, the intention is for it to be extended based on the UK ROC data set. It considers a wide range of therapy plans, hydrotherapy, gait training, and a combination of one or more of these plans, and recommends intensities, duration, frequencies, cost, and the treatment burden. And of course, we have got the different modalities here. However, this can be extended to really reflect an extended therapeutic plan features. And of course, the functionalities can be driven deep down to provide much more granular recommendations. It is not static, but dynamic. For example, if a certain patient's data is provided, age, which can be toggled, and as you can see, as it's toggled based on the patient's data and information, it changes. Income, gender, whether male or female, a school level, again, which plays a huge factor, ethnicity. Now we have used A, B, and C, but can be extended, and a set of clinical and physiological scores. They have the NIH scale, modified Rankin scale, up to the commodities. Again, these can be extended. Now, with a specific patient data already, entries made there, and of course, with such modifications, we can see it gives us the different kinds of therapeutic plans, and of course, the intensity, duration, and the rest, and the scores. Now, for this particular patient that is of age 60, income almost 80,000, a male who is a high school graduate, ethnicity belonging to A. A could be white, Black, Asian, depending on what the actual data tells us. And the clinical scores, again, which can be toggled for this particular patient. What we get is a patient who is now recommended a therapy plan 4. Now, therapy plan 4, based on the AI engine that runs beneath it, having the highest probable score here, and also the score still reflects in the detailed utility score. Question is, what does plan 4 represents? Plan 4 represents hydrotherapy, cognitive rehabilitation therapy, dietetics, nutrition, and gait training. Now, a combination of all these would require an intensity of 9. Again, once we have the actual data, this will be extended on training and for a duration of 35 days and a frequency of 4, probably times in a day, depending costs and what the treatment burden is in this case, which is 12.9. And as you can see, this treatment plan for this particular patient is somewhat different from the treatment plan for the other treatment plans. Now, this will differ if we begin to change the type of patient we want to plan for. And as we can see, it is changed in this case, and it still shows now if this were a female, plan 4 still represents the highest score. If we decide to change to a PhD, plan 2 becomes the option to go with. And for plan 2, in this case, hydrotherapy, and of course, we can see what the utility scores point to. Again, this is not a static tool. It is very dynamic. And as we can see, it supports what if scenarios. Here, what if scenarios? What if this scenario becomes a high level of stroke scale score or high level of the modified ranking, allowing the clinicians to explore how adding a new therapy or changing a variable could impact the patient's likelihood of success. And as we move forward to extending this tool, we aim that it should empower the clinicians, the care providers to co-create and provide the most effective and personalized plan. To round up, it is more than just a tool. It is a new approach that uses an AI engine that runs behind it, and of course, employing the human behavioral economics and the cognitive bias as part of the development to understand human preferences. With this, we can move from a one-size-fits-all care to a truly personalized, efficient, and effective treatment. I must say, this tool has the potential to transform patients' outcome and optimize resource allocation within the NHS.